Recognition is just going to come from practice. You already have the best algebraic techniques you could possibly have, I think, at this point. So basically, you just need practice on this, recognizing what you're going to use when. So let's start with A. Okay, so take a look at this and tell me what you think it could be. Okay, so when we're integrating a fraction, what are our possibilities? Okay, so we have arctangent, we have arcsine, if there's a fraction. We have our rule number 14, where the derivative is the top, and then we basically have u substitution. You can use general rule, which is just kind of a quick and easy version of the u substitution. Okay, so we have those. You also can do long division. You can also separate fractions. Okay, which we did one of those examples, I think, in the last section, in the last problem. So, things to think about. So, this one is, Tyler nailed it. It is a arctangent. Okay, so if you rewrite this, they write the dx up on the top. Okay, but don't let that confuse you. That is the same as 1 over 1 plus x squared dx. Okay, so this is like literally the arctangent definition. Okay, so it is just the arctan of x plus t. Very straightforward. Okay. B. What do you think for B? Okay, yeah, so let's try. We know that it can't be an arctangent because the x isn't squared any longer. Okay, so let's try rule 14. What is the derivative of the bottom? 1. So if I rewrite this and pull the dx off, I would have a 1 on the top. So is 1 the same as 1? Yeah, so this is a literal rule 14. I have to do nothing. I don't have to multiply or divide by anything. So the answer would just be the natural log of 1 plus x. Okay, what about C? Okay. Okay, so this one might require a little bit more writing. So the u for this one would be 1 plus x squared. So what's the derivative of that?
2x.
2x. So is 2x exactly the same as x? No. What do I have to do? Multiply by 2. Now if you can do that in your head and just go ahead and throw the 1/2 out in the front and go straight up and integrate it, that is totally fine. In fact, I think that's how the book does it. What? What's the metaphor?
Yeah. What was the writer trying to do? Oh my god.
I think you're looking a little too deep there. Okay, what about D? This one is different. They have a quantity. So anytime you see a quantity, good, very good. Okay, so do you see how that should be like a really obvious u substitution? Okay, you have a quantity with an exponent. Quantity with an exponent is u substitution. Okay, so my u is going to be the piece that's in the parentheses. So we have the 1 plus x. What's the derivative of that? 1. Okay, 1 dx to be technical. Okay, so is that what's on the top or what's left over? It's exactly what's left over. So I can do my rewrite in terms of u. So is everybody okay if I do u to the -2? Just pull that straight up and do a du. So now I have my basic integration. What's the integral of u to the -2? But I'm pulling it up so that I can integrate it, because it would just be 1 over u squared, right? 1 over u squared. So if I pull that up, it becomes u to the -2. So now I can integrate it. If it's in the bottom like that, I can't integrate it. I have to integrate it when it's in up. So if I add 1 to negative 2, I get negative 1. So I'm going to have, ooh, okay. You're ahead of me. I'm going to do it slowly. So I'm going to have the u goes into the bottom. Can I go ahead and replace the u? And go 1 plus x plus c. Okay. You'd have to do, if you integrated that one, that would be basically b, but you'd have to multiply and divide by a negative. Interesting. Okay. Ooh, interesting on this one. Lookalikes. Well, I guess the only difference is the natural log is on the bottom versus on the top. Otherwise. Yeah. So. So, how are we going to do this one? So, do you notice that we have two things that are being multiplied in the bottom? Okay, so since I don't have, basically I just have a 1 at the top, right? What I can do is I can separate it. So, do you see that this is equivalent to 1 over x times 1 over the natural log of x, dx?
And 1 over x
of, okay, so what am I going to do?
That's what did we just say? That's a 14, right?
Okay, yeah, it's exactly a 14. Okay, so do you guys see how this is a rule 14? It's very tricky because usually you say, is the derivative in the top? But what's the derivative of the natural log? 1 over x, which puts it in the bottom. Okay, so it's like this is your u for the rule 14. The derivative of that is 1 over x. So this is going to be the natural log of the natural log of x plus c. Which feels super wrong to me when I write that. Like, oh man, I must have done something wrong. It can't be, that can't be right. Rule 14. Yeah, you want me to write that? Rule 14.
It's not even a number. So this isn't even that.
So we're doing English, you think?
Oh.
It's not even a sentence. Okay, what about B? Okay, so do you see, I can rewrite this one kind of similar to the way I did the last one. 1 over x times the natural log of x.
Oh, the derivative of this can be a rule 14.
It's not a rule 14. It's one of the very first ones. It's a general power rule. Yep. So your general power rule, you guys see how general power rule, if you look on your integral sheet, it looks like, what does that even say? Yeah. So even though this is the notation, we know that you have to divide by the derivative of your n piece. So this is like my n. So it's technically to the first power, right? Okay. So I can integrate that. Ignore the 1 over x for a second. What's the integral of the natural log? Or, sorry, I have to say, my bad.
Oh, no.
So the derivative of the outside, so it'd be, how should I write this? 1 times the natural log. No, hold on. Because it goes the natural log squared over 2, right? And then you have to divide by the derivative of the natural log. So what's the derivative of the natural log? What's that? Yeah, because you're right. It doesn't say it on the sheet. So yeah, because of the notation, they put the derivative in the front. So it's like they have the hook-on factor on the first part, so you're undoing it. So on the definition, so that's like one thing that this doesn't say. So like maybe I should write that on here, is that on the integrals you always divide by the derivative of the u, and with derivatives you multiply. Yeah.
So x over
1 over.
1 over x.
So if this is done correctly, the 1 over x should cancel. Otherwise, I would have had to use a different method, but they do, so we're okay. So this is just a general power rule. So we're good with that? Okay, so let's see what this little paragraph says. So these are the simplest algebraic techniques that we have used to fit integrals into forms which appear into the basic integration. So we can do the multiplication expansion. So that's one of the things we did above. So we expanded it so it looked more obvious to us. Term by term division. So that's like, this one is like your, let's see, if you have x plus 4 over 3, this idea, where you can separate it to 2 fractions, x over 3 plus 4 over 3, that scenario. Okay, long division, that's kind of, in my opinion, that feels like a last resort, but I don't know. And then splitting the numerator. So let's do some more examples and see what else we can do. Okay, so what would your instinct be on this one? I don't know if your instinct would be the same as my instinct, but there's two things you could do. No instincts at all? Okay, so instinct number 1 is I have a quantity that has an exponent. So usually if you see a quantity with an exponent, what do you think? U substitution. Okay, so that's an option. Or the other one is I just have a quantity that's squared. I could FOIL this and then just do basic. So when I look at this, if I have something to square, that's pretty simple, and I know that I can use basic. That's going to be pretty basic. So I'm going to FOIL this. So if I have e to the 2x squared, what does that make? E to the 4x. And then I have minus, and it's going to be 2 times e to the 2x times 2. So minus 4e to the 2x. And then it's going to be plus 2 squared. So 4. So that's just your basic foiling. And then I just integrate this. Okay, so do you remember how to integrate e to the 4x? That one you should remember by now. It's pretty simple. Close, just 4, because the derivative of 4x is 4. So 4 e to the 4x minus, what about the next term? Can I say 8? 8 e to the 2x? Oh, I'm doing this wrong. I'm deriving. Guys, you're supposed to catch me. Were you wondering what I was doing? Oh my gosh, my bad. You thought that was new? That was derivative, so we have to divide by 4. So you do, well, you don't add 1 to the exponent on an e. That's only with it if it's an x. So it's just, you just divide by 5. You divide by the derivative of the 5x. Well, that would be like if it was, let's say, x to the 4. What's that? Yeah. Oh, that's what you're saying. Sorry, I did not hear that. My bad.
But you still add 5x.
Add 1 to the 4. No. Oh my gosh. Yeah, okay, I see what you, no. Let's just start over. Okay, I got this. My bad, you guys. I'm trying to confuse you as much as possible. E to the 4x over 4. There we go. I'm pretty sure that's right now. Don't add 1. That's only if you have x to the 4th. On an e, it's just divide by the derivative. Oh my gosh, sorry about that. So then this one would be 4e to the 2x, and then you divide by the derivative of 2x, which is 2. And the integral of 4x, there we go. There we go. My bad, you guys. Jeez. So then we could say 4 halves is 2. There we go. That was supposed to be an easy one. Huh? Build a snowman? What does that mean?
It's frozen. You guys get that?
Now I do. So if you have one thing in the bottom, you have 3 things on the top. This one is really simply just divide it and put it into standard form. Okay, so remember that this is the same as x minus 2x to the 1/2 plus 1 over x to the 1/2, right? So we're just going to simplify and divide each term by it. So if I have x over x to the 1/2, I subtract exponents. So what does that become? So it's 1 minus 1/2. Close. Positive 1/2. Okay, what's my middle term? If I have 2x to the 1/2 over x to the 1/2, the x's cancel, so I'm just left with 2. And then on my last term, I have 1 over x to the 1/2. I'm going to pull that up, so it'll be x to the negative 1/2. Okay, so this is going to be another basic integration. This is the one where we're going to add 1. Okay, so what's my integral of x to the 1/2? So it's 1/2 plus 1. Three halves? So, and then I divide by 3 halves. So can I go ahead and just say times 2/3? So minus 2x. And then if I add 1 to negative 1/2, that's 1/2. So x to the 1/2. Divide by 1/2 is the same as multiplying by 2, right? Done. Okay, so that's an easy method to use. Okay, what about number 5? Quadratic formula? That's an interesting point to make, though. You have a quadratic over a quadratic. What's that? Mm-hmm. So it's definitely not a rule 14. It's definitely not an arctangent. You can't do a U substitution. So what's kind of our last method? This one is a long division one. You have to rewrite it. So you're going to have x squared plus x And then underneath we're breaking x squared minus x minus 1. Okay, so what do I have to multiply x squared by to make it x squared? 1. So then I multiply that through. So I got 1 times x squared, which is x squared. 1 times x is x, and I subtract. So my x squareds go. How many x's do I have? Nice, good. -2 x's minus 1. So now this is my remainder. So I can say, I notice that I have 2 negatives. I'm going to write this as minus 2x plus 1 over x squared plus x. So I'm going to pull the negative out, and then I won't have to worry about it. So my rewrite is the integral of 1 minus the integral of 2x plus 1 over x squared plus x dx. Okay, so what's the integral of 1? That's pretty simple. X. Okay, what about the second one? What rule is that? What's the derivative of the bottom? We're almost done, guys. Give me 1 minute. 1 more minute. I won't do the last one with you. What's the derivative of the bottom? 2x plus 1. So it's exactly the same. So what rule is it? What rule is it? 14.
Oh, yeah.
Goodness. Natural log of x squared plus x plus c. Done.
Oh, that was 16 seconds.
Okay, so I'm gonna save number 6 for when. I'll just save it for Friday. How about?
Sure.
And I'll do. Maybe I'll do that one for a warm up.
We don't have an assignment, right?
Oh yeah, you have an assignment.
But what about those kids that are gone?
They also have an assignment. 21.
Hey, I just want to make sure they turn it in on Friday. 20 is a school-related event.